All right, number 17, we want to find the derivative of the function x minus a divided by the square root of x minus the square root of a. And we're told that a is a constant, so we're going to treat that just like a number. We're going to have to use the quotient rule. So when we find the derivative, we're going to do the bottom times the derivative of the top. So doing each separately, this will be 1 minus 0, so the derivative of x is just 1, so we'll just multiply times 1, which won't change the first part. So bottom times the derivative of the top minus the top function, x minus a, times the derivative of the bottom. Okay, so when I do the derivative of the bottom, I'm looking at x as an exponent or an exponent notation. So instead of the square root of x, I'm thinking x to the 1/2 power, and again we're going to multiply that and then subtract 1. So that will give me 1/2 x, and then you subtract 1 from a half, that will give you a negative 1/2. Okay, and then the derivative of a, which is going to be a number, is going to be 0. So bottom derivative of the top minus top times the derivative of the bottom, all over the bottom squared. Alright, and then we don't have to simplify it. I just want you to do the derivative here. I will get rid of the 1. Times 1 won't change anything. And I might move this term out front. So we'll say the square root of x minus the square root of a minus, we'll say 1 divided by 2 x raised to the negative 1/2 power, and then that'll be times x minus a, and then we have the square root of x minus the square root of a, and that is squared. Alright, so next, number 18, we got 4 parts. It says determine if the statements in part A through D are true and give an explanation. So part A, we are finding the derivative of e to the 6th power, and they're showing you what looks to be the product, not the product rule, the power rule. However, e is a constant. Okay, so when you take the derivative of a constant raised to some power, you still get a number, constant, and that will just be 0. So we will not use the product rule. The power rule. We're going to say false, and that the derivative is going to be 0 because that's a constant. Part B is the quotient rule, and they're showing that you must use the quotient rule to evaluate this. However, you can simplify that. You can say x squared over x, and then plus 3x over x, and then plus 4 divided by x. You could do this and rewrite the function like this, or even write this as 4x to the negative 1, and then you can do the power rule with all of these. So you can do the quotient rule, but you can also simplify it, possibly. And so that's what D is showing. You're going to do the derivative of each of those individually. And you could use quotient rule there, but you can also do this. C is showing the quotient and saying it looks like they're using the quotient rule. It doesn't look like what they've done is a quotient rule. So if we look at this, if I wrote this as x to the negative fourth and did the derivative, you would multiply by negative 4 and then subtract 1. And so you can rewrite that as negative 4 divided by x to the fifth. So this is what you would get, and that is not what we have here. And so we're going to say false. D is going to be the correct answer choice. And then E, we have product, so it looks like we're going to have to do the product rule. 1d2 plus 2d1, and that does not look like that is it. So C looks like to be the best one using the product rule. This one looks like they just did the derivative of the first times the second, and not the second times the not the first times the derivative of the second. They do it a little bit backwards from me. But C would be the one that shows the correct product rule.